Okay, I want to talk a little bit more about testing errors. Again, when we're doing hypothesis testing, we're trying to prove something through a statistical test. And we want to have an answer such as, we have found that we can see statistically significant differences, or we don't. But keep in mind, any test, there's always a chance that we made an error, made a mistake. And these are even if we do everything correctly. There is always a chance that we identify that there has been a difference when in reality there's not. That's what an alpha error is, which is also called a type 1 error. It's also called producer's risk. And the origin of that, and from producer's risk, let's say that we have an error. We think something has shifted. We think something has changed. And what should we do? Well, that means we go investigate it. We go try to fix it. We stop producing, or we stop what we're doing, and we try to brainstorm and come up with solutions. But remember, this is an error. That means in reality nothing is wrong. So we incur the cost of investigation. In reality, there's nothing to investigate. That's producer's risk. The other kind of error is when something bad has happened. Well, that's a bad way to say it. Something has changed, but we do not detect it. We failed to detect a difference. And that's called consumer's risk. And all that means is that the group of people that are exposed to it first are the consumers. Think about if you're manufacturing Tylenol or some medicine, and you have some quality control and you're testing, and let's say something is wrong. Something has changed and you're producing medicine that you should not produce. Well, you should stop it, right? But remember, your test, a type 2 error, is when we do not detect it. We think there's nothing wrong. In reality, there is something wrong. So that means that we're going to get a bad product out into consumers' hands, and the initial disutility is by the consumer. So it's called a type 2 error, beta, consumer's risk. It all means the same thing. I'll just say up front, even after we go over these complicated graphs I'm about ready to show you, just by convention, we establish alpha to be 0.10. We try to set it up to be 10% or less. Beta is really a function of what we're concerned with, how much it would shift to, and I'll show you what I mean by that in this spreadsheet. So I've got a spreadsheet out there called testing error. And you got to, what we have, let's say that we have a process, and it's a good process, it's doing fine, and we're testing though because we don't want the process to shift. We don't want this to happen. We don't want it to move. We want it to stay centered at 10, and let's not worry about the variability. Let's just say that that's the variability right now. So you can see we make, or we're producing product or service centered at 10, but we do have some variability in it. Now, you have to remember is that with this process, we're going to get occasionally some low numbers. You can see it's possible. It doesn't happen very often, but we're going to get some low numbers, and we're going to get some high numbers. But we've got to come up with a rule that if we exceed or less than, but let's just focus on the right-hand side. If we exceed a certain number, and that's what I have here, this is the rule. If we exceed this, then what we're seeing is that in reality the product or the process has shifted. So as long as we get a sample and we get a number less than or equal to our rule, we're going to say the process is like this. But if we get a high number, something high out here, we're going to say, although that's possible, we don't think it happened. We think the process has shifted. We think that, so if we would pull a high number, let's say around 18, rather, even though that's possible, we're thinking the process has shifted somewhere out here where an 18 is very possible. So the question is, what is our rule that we want to put into place? And you can see right now, I've got a rule of 15. So that means when I pull a measure from a process that I think is centered at 10, with the standard deviation of 3, and I grab a value that's higher than 15, I'm going to say that that process has shifted. I'm going to start doing things to correct it and bring it back to 10. Now, what does that mean? Well, hopefully the process is truly shifted, and so when we start investigating, we can move it back. But let's say the process has not shifted. Let's say we just happen to pull a high number. Well, then our type 1 error is any area to the right of my rule. So this is my type 1 error. And in this case, my type 1 error is 5%. If I try to make it smaller, like that, if I make this smaller, then my type 1 error drops to 2%. So the further I go to the right, I can make my type 1 error smaller. So if I set up a rule and say, well, I'm only going to investigate if I get a high number that's higher than 16. That means 2% of the time I'm going to go investigate, and in reality there's nothing wrong. Okay? So that's a type 1 error. But keep in mind that there's also such thing as a type 2 error. A type 2 error is when the process has shifted. It's moved, okay? It's shifted to the right. So let's add some reality. Let's say this is the existing process, but let's say it truly has shifted. Let's say, I'm going to say out to centered at 15. Okay? This is the old process, and the purple is now the new process. The red one doesn't exist anymore. The process has moved to the right. Now remember, we have a rule in place. We have a rule in place which is, let's make it something where it's not setting right on it. Let's say it shifted to the 14. Let's say it shifted from 10, centered at 10 to 14. Okay? So if it shifts from 10 to 14, I've got a type 1 error, but now don't look at the red chart, or the red graph, look at the purple graph. That's what the process has shifted to. But remember what my rule is. My rule is that if I get something greater than this green line, I'm going to say something is wrong. That's my rule. Well, look what can happen. I can shift to the purple, but as long as I pull a number less than or equal to this green line, I'm not going to detect that shift. So the likelihood that I'm going to be able to detect a shift from 10 to 14 is anything on the right side. Or the other way to say it, my type 2 error is the area to the left of this green line on the purple. That is my type 2 error. So even though I've got a type 1 error of 5%, my type 2 error is 63. Does that make sense? Now what if I want to try to always make my type 1 error smaller? Let's make this 16. It goes down, but look what happened to my type 2. It increased. The further you go to the right, with your rule, trying to make your type 1 error smaller, you increase the type 2 error. So our goal is to establish an alpha and beta that's hopefully small. Usually we try to set this and this. We're trying to set a rule so that this is, we establish this to be probably less than 10% and usually this less than or equal to 15%. That's our plan. And we'll talk more about that when we get into hypothesis testing. Let's say that we're not really, it's okay if we got to shift to 14, but let's say the process shifted way out to 20. Well, that's pretty good. So the process, having a rule set at 16 is pretty good in the sense that if it happened to shift to 20, the chances that we would fail to detect it's only 10% or 0.09, and our type 1 error is that. And I could probably actually make that 15. This goes up, but this went down, and that might be the ideal. That might be setting something like that. Okay, that's we're setting in both the 10%. Maybe we want to go maybe 15.5, and set this a little bit low, but set that on the high. They don't have to total to mean anything. That doesn't mean anything. But that's hopefully an introduction to what alpha error and beta error are. Thanks.